So this tutorial is about coding guide, coding style. We swapped this tutorial and the last tutorial, which is debugging, because we want to get you to have an earlier sense of the coding style while you are still working on your code. Why does code style matter? Your code is written once and read many times, modified many times, often not by the original author, and the original author won't remember everything they wrote. So the goal is to write code which is easy to read and understand. Code which is hard to read is bug prone. When you're trying to debug, you won't be able to follow what was done. It's difficult to modify because you must understand it first and then modify. And it's challenging to reuse. Today, we're going to cover guiding principles on coding style, aspects of coding style, functions, variables, comments, avoiding duplicate code, grouping data into classes and structs, and have no warnings. Up to here will be graded by your TA. Self-checking code and many others are optional and could be counted towards bonus. Guiding principles. Why do we need to make codes that are easy to read? And how to do it? First is to reduce the cognitive load for the reader. Programming requires understanding a lot of details. When you're reading a piece of program, you'll need to keep in mind about all of the variables in scope. What are they doing? The stack, and a lot of other details. Human working memory is 7 plus minus 2 items by Miller's law. If you exceed this many of items at a time, your code is hard to read because the reader needs to flip back and forth to see what they have forgotten. Try to minimize the number of considerations at a time. Your coding style should explain why, while your code explains how. The original writer understood like why you're writing this code this way, but the reader needs to understand it. Usually you cannot ask the original writer about how they wrote this thing, why they chose this algorithm to write this part of the program. Usually you can ask them, or usually the original writer will forget. So keep in the documentation by using coding style. Functions, variable names, temporaries. Keep your functions short. By Google, most functions should be 40 lines or less, and this will be checked by your TA. Longer functions are hard to read, understand, and maintain. Shorter function will force you to name parts of code into helper functions. This helps you organize and structure your code better. Your functions will overgrow over time, especially your load map. Each time, if you just think you just need to add 2 more lines to this function, after 10 times, your function will grow by 20 lines. Refactor this to extract new helper functions to keep your functions short. Variables. Good variable names can describe their contents and their purpose, so that the reader does not need to look at the declaration where usually you will have a line of comment explaining what this variable does. The reader wants to get the information from the variable name. Try to minimize the number of variables in scope And this helps reducing cognitive load so that the reader doesn't need to remember too many variables in scope. And be mindful of temporary variables. When you're adding temporary variables, only add those that help the readability and add information. If it's just simply renaming variables and are not really saving your typing, not really helping you with readability that's too clear, should be avoided. And I'll show you in a later example. Let's look at this example. So all of the names are chosen to not be misleading. All of the namings make sense for the purpose of this program, for the purpose of this function. Let's take a minute to read it. And can anyone tell me what this function does? Okay, can anyone tell me what this function does? Any ideas? Yep.
There's not really like just like attributing like a bunch of calculations through the for loops.
A bunch of calculations through the for loops. How about this? What does this do? It's the same function, except it's calculating the integral between two x values for 1 over x. We simply rename the variables from this to this, and we see the difference. For a definite integral, calling it di makes perfect sense. For integral, we integrate from a to b. Makes perfect sense. We give the name value to the final value being returned. Makes perfect sense. We give the name d to the step size. Makes perfect sense in terms of an integral. But if you do it like this, it's clearly easier to understand. And you can understand this within 1 minute. General guidelines for naming conventions. Variable names should be descriptive, often in multiple words. Discuss within your group to decide whether you want to use the underscores to separate words. This should be all small alphabets underscored, separated. Or use camel case. For variables, always start from lowercase letter. constants, either choose start with K or all capitals. So this design choice is going to be chosen within your group, but you have to be consistent. You shouldn't be mixing the two conventions. For functions, follow the same convention as what we gave. Type and class names should always start with capital and use camel case. Consistency is the key in the naming conventions. So make sure all team members in your group are following the same naming convention. Let's look at this function. It's the find street segment length function. Any thoughts on the coding style? We're not looking at comments yet. Do we have any thoughts on the coding style? Does the code look crowded? Is it easy to understand? Is it easy to read? And what are the problems then?
It's like the whole text is started, like, it's very like paragraph.
There's no vertical white spaces. Break into paragraphs. And now, what's the next problem? There are many function scope variables that are declared at the top of the function. And when you're reading through this code, you'll have to keep in mind what variables are declared here and read. And this introduces potential initialization bugs because you might be expecting some of those to be initialized and some of those to be not initialized. And sometimes that's not the case. And length is only used in this if block. And the other three variables are only used in this else block. And that's also not good. You don't have to have those variables that are only used in one block to be declared at the function level. Declare variables at the smallest scope possible so that the reader don't have to remember those after it exits that scope. And where they can be initialized. Initialize when you make them. So now we deleted those function scope variables and put them into the if and else statements. The variable names are also not descriptive enough. Inter1, inter2, lat long 1, lat long 2. Inter1 and inter2 are obtained from info.from, info.to. And here we are losing the from and to information. The ID is a street segment ID. but we are just calling it ID. And that is a problem. There are also redundant temporary variables. Inter1 and inter2 are only here and put into here. Why not we just put info.from, info.to into the parentheses? So use descriptive variable names and avoid temporaries that do not improve clarity. So we rename the ID to streetsec ID. We rename the info to seg info for info on street segment. We remove the two inter1, inter2 and put the seg info.from.to into the parentheses to call the get intersection position. Doing those, we have minimized a lot of lines in this function. And we rename the lat1, lat1, into position from and position to. This preserves the from and to information. The length is another redundant temporary variable. You don't have to have the length. You can directly return from that function. And now, are the position from position to also redundant temporary variables? And do we have to also eliminate those? Any ideas? First, are they redundant temporary variables? Do we have to have them? We don't have to have them. Then do we need to eliminate those? This is what it looks like if we remove the use of those two variables. We actually have too much in one line. We have 3 function calls in one line. And that actually adds on the difficulty for reading. So in this case, these two temporary variables are actually helping you read. And this also helps you step through the debugger. So it's not necessary to remove those two redundant temporary variables, even if they're not really required. But in this case, it improves the readability and add information. So we went from before to after. See, we have removed a lot of lines that are not really needed. And we have white spaces and everything that makes this piece of code more readable. Is this good? Comments. I'll show you a few types of comments that are already provided to you in the header files. So at the top of the .h files, for APIs, we have huge block comments that contains the information of the API, how to use it, and everything. Before each function declaration, we have a few lines of comments explaining what this function does. Before each struct or class declaration, we have a block of comments with information about the struct or class and how to use it. And most importantly, why we are implementing like this. Inside the struct or class, for each field, there is a line of comment explaining what this field does. In each code block in your .cpp file, there is one line comment saying what this code block does. Which of these are the most important? So the key idea for commenting is to always have the high-level comments. Your comments should be your documentation of the code. Your documentation shouldn't be in a separate document that will get out of date. For your code to be maintainable, always keep the documentations inside the code using comments. And modify the comments whenever you modify the code. The most important comments are those that give the big picture of your code. That describes the why, the overall structure of your code, the design choices you're making. These are the 4 places to put your comments. On the top of files, that's usually where you describe why. And usually where you describe the overall structure and design choices. Always keep them. Always write one for each of the file you add. Class data structure definitions. This really helps on understanding the data. In most cases, understanding the data means understanding the program without even reading the program. Declaration of functions, how to call, what it does. This is also important, but for each function. Tricky bits of code. For each tricky bit of code, try to rewrite for clarity first. If it's not clear enough, put one line of comment for the code block. Do not leave commented out code in your project. This will make your files big, and Git has all your code history if you need to look back. So do not leave commented out code in your project, especially before submission. Remove all commented out code in your project. And do not translate clear code to English. If the code is doing addition and you just say do addition, then that's not necessary. And the rank is from most important to least important. If you don't have comments for 1, 2, 3 at least, you'll get mark deductions. Now look at this function again. For the definite integral, where are the places to place comments? Any ideas from anyone? Yep. Mhm. Mm. Mhm. Top of the function with a comment about what this whole function does. That's the most important comment we're looking for. And tricky bits of code. The for loop, everyone knows it's a for loop that goes from left to right and incrementing by step size. When we're doing the comparison, have a comment saying why are we doing this comparison. When we're doing the averaging, have a comment saying why we're doing the averaging, because that's not obvious enough. So only comment on those things that are not obvious enough. Is this good for comments? Duplicate code. Avoid duplicate code because this is a thing that's most likely to happen. You're most likely going to copy and paste some portion of your code to do a very similar but different functionality. Try to extract those into their own functions. Say in this for loop, we have two blocks of almost identical code. In both cases, we are trying to make sure the ID is not a duplicate for the ss.from intersection ID. And in here, it's the ss.to intersection ID. So the two blocks are almost identical. They're doing almost the same thing. So we want to extract the duplicate code into a function and call the function twice with different parameters. So then after extracting those into a function called insert unique, this for loop has two calls to the function now. Do we have to do something to the comments after the change? Are the comments looking okay? No. Do we need to add more or do we need to delete some? Yep. Yes. The comments are a bit wordy and repetitive because we're having two almost identical comments for two calls to the same function. So we combine them, combine the two calls to the same function into one code block and have one comment saying, why are we doing this? The comments are now succinct at higher level that describes two lines. And now I'll show you the demo on how to use the IDE code tools for code refactoring. I'll do the same demo for VS Code first and then for NetBeans. So this is the same code that we implemented the last tutorial for find three segments of intersection. In load map, we are loading in the intersection three segments global variable that's defined here. We'll need to add more comments, but that's not handled by the IDE. It's handled by the program yourself, so I won't be showing that. So what's the first problem we can see with coding style here? Yeah. It's crowded. So I'll add vertical spacings. What else? That's pretty obvious. Yep. The brackets and the indentations. So in VS Code, you can do this to fix all the formats. And there are also no spaces here. So we can highlight, right click, format selection. Oh no, it's getting slow today. Yeah. So this is how VS Code formats your code. It will put the brackets on a single line, and it will fix the indentation and the spacings. How about the variable names? Is num really a good name to use here? We want to keep the information that num is the number of intersections in the name. In VS Code, same. Highlight, right click, and do rename symbol. And in here, I'll change this to num intersection. Enter to rename. This rename feature in VS Code does a smart rename that only renames the variables in scope. So it won't touch any other num that's outside of this scope. The I'll rename it to intersection ID. This X is also not a very good name. There's another trick in VS Code because I'm only modifying the 2X. I'll do Control D, and this will highlight both of them. Then I can do intersection C segment. But be careful that this is not a smart rename. This will modify things that this might modify things that you don't want to be modified. So if you want to do a smart rename, use the feature. I'll keep the others the same. And I'll go to the terminal and prove to you that this is still working. I want to run only the functionality test for intersection. So it's passing one of the three tests, and that's the only function that we implemented in here. Okay, I'll revert everything. And another thing is that this should be extracted into its own helper function, but unfortunately, our version of VS Code doesn't do that for you. That should be done manually. Yeah. You don't have to add more comments to the header files that are already provided, but for your own header file that you're making, most likely you'll make your own header files for, especially for the later milestones, you'll have to add the block comments. Okay, I'll show you the same things on NetBeans. There are actually benefits for NetBeans because it won't get as slow as VS Code. And it has the functionality to introduce functions. So the same thing, I'll do the vertical spacing first. And we want to format this function. How to do it? Same thing, highlight, right click, format. This is how NetBeans formats your code. It will have the open bracket the same line as the declaration. I actually prefer this one better, but both works. Just keep in mind that you need to be consistent. And it fixes the indentations and all the white space. For renaming, let's rename the num. Highlight, right click, refactor, rename. And in this window, you can rename the num to num intersection. And this, similar to VS Code, is also a smart rename that does rename all the variables in scope. I to intersection ID. And if you want to keep it shorter, you can do inter ID. X to refactor rename. Now inter street segment. J to inter street segment I. And when we are calling this function, there's no chance for us to mix these two. But there could be a chance for us to mix I and J. That's for renaming. Now, we want to extract this chunk of code that is only doing populating the intersection street segments into a helper function. We cannot do it in VS Code, but in NetBeans, we have right-click, refactor, introduce function. How do you call this function? Populate intersection street segments. If you need to introduce functions that do a different functionality, you could specify the return type and the parameters here. But in this case, we don't need any return type or parameters. It's just doing the same thing. I can directly do refactor. And it refactors into one function call where the function is here. You will, of course, need to add comments to all of the code shown here. And to prove that I have not broken anything, I'll make again and ECE297 exercise 1 round tester function intersection. Good? Everything good? Okay. Next aspect in coding style is always use named constants, not magic numbers. I get this very often in previous years, even though I keep emphasize. This code does, it loops over an array with weights. The size is 20. When it sees something that's less than 0, it returns -1 and exits. When it sees something that's 0, it returns 0 and exits. If there are no -1s, no negatives or no zeros, it returns 1. So it returns 1 when all of the weights array are positive numbers. And we see a magic number 20 there. A big magic number 20. If we change the array size, we must find and change all 20s within this function. And if we miss any one of those, there's a bug. It's also returning magic numbers -1, 0, and 1. We must read the code carefully to see what each means. In this code, it's simple enough that we can know it right away, but always keep a habit of not returning magic numbers. Defining constants for all your numbers. In C++, you can do it in 3 ways. First way, using a constant variable. Const int num weights equals to 20. And remember to capitalize all constants. A constant variable is a variable that's being declared at runtime. The preprocessor constant, which use the hashtag define, defines this constant at compile time. Both of those work, and in ECE297, those mean the same thing. We can also use the enum type. We define an enum type weight return that has neg, has 0, and all pos, because the return types can be grouped together into one type. And now we can use the constants in the code. The 0 doesn't have to be a constant because it's obviously 0. There are 3 ways to make constants all work. And one benefit of using the enum type is you can change the return integer from int to enum weight return. And this ensures that only certain integers, those are named in the weight return, can be returned. If we accidentally are returning something that's not valid, we can detect it right away. Is this good? Now, the next demo is on eliminating warnings. So in the source file, we have the same function, check weights. And we have the weights and the call in the main. So we see that the weight starts with a -1, so it should be returning a -1. Right. Now let me open up the make file and I'll turn off the warnings. So this -w all enables all warnings. Now I'll delete that and I'll disable warnings. Let me do a make. So compile passed with no errors. We disabled warnings so we don't know about warnings. And let's run it. Our expectation is to see a -1. But we're seeing a 1. What's the problem? This is the problem. Let's put back the warning. We will make clean and make. Aha, we have one warning. Compile warning. It says on line 11, suggest parentheses around assignment used as truth value. But we're meant here to do a comparison, not assignment. So that means we are missing an equal sign. That's on line 11. Here. We're missing an equal sign here. So the program is treating this as assignment. So we fix this. Go to your terminal, do make. No warnings, no errors. And let's run it. And it gets -1. So there are actually warnings that could help you debug. And that's why we're asking for no warnings in your program. Do not have any warnings in your code because there are some warnings that could flag problematic code. If you leave some warnings in, those useful warnings could actually be buried inside all of the warnings that you're ignoring. So fix any warnings right away and stay at 0 warnings. Your TA will look at the number of compilation warnings when they're marking you, so be careful. -w all is the compile flag that tells the compiler to generate all useful warnings. And this is turned on by default in your makefile. That's good for warnings. Group related data into classes. Say here, we have 4 global variables that are vectors, and all of those contain information about segments. We can group those 4 informations into one class or struct called segment data. The first one is from intersection index to intersection index, speed limit, length of segment. And this brings us down to one vector of segment data that's global. This helps us group related data structures together, so it helps us read your code. You'll see what's related. And this is also helpful for you to have more meaningful variable names inside the segment data class. And globally, there is just this one variable name that is being taken. So there's less name pollution. And if you need to access any one of those, you just say segment info, which index dot from intersection index. So it doesn't take more time to access anything. It's just a better way of writing the code. Defensive coding. Let your code find bugs for you. Defensive coding is usually not really required when your TA is grading you, but it's still a good thing to have and could contribute to bonus. Yeah, sure. I'll post the recording online, so make sure you're watching whatever you missed.
Oh.
Yeah.
You
Defensive coding. First aspect of defensive coding is use assertions to verify assumptions in your code. Even though our test cases will not give you not invalid intersection IDs, some of the code that you might experience might be doing so. So having an assertion is a very good practice. When we are taking in the intersection index intersection ID, we are always assuming that it's a valid ID that's from 0 to number of intersections minus 1. So we put an assertion checking whether this is greater than or equal to 0, and that this is less than the intersection street segments dot size vector. If we do this, this will exit the program if the intersection ID is out of range or the intersection street segments vector is not loaded. And this will give you this message saying it fails the assertion at this line. This is better than a comment. This checks your correctness of your program at runtime, and it gives useful error message. And it prevents your program to execute further given an invalid intersection ID or a global variable that's not already populated. But assertions might slow your program down because assertions take a lot of time to run. So before you actually test your performance tests or submit, add the define and debug. This should be before the inclusion of the assertion library, assert.h. And if you do this, this will turn off all of the assertions. And this will not affect your speed anymore. Second aspect, set the deleted invalid pointers back to null immediately. In case PTR is going to be used later. If PTR is going to be deleted right after the deletion, you don't have to do anything. But if it's not, put PTR to null. And this will ensure whenever you try to access PTR again later, it will segfault immediately. If you don't set it back to null, this might actually give you garbage values, and this will make your program run further. And this will become more and more harder and harder to debug as this error propagates further. So try to crash as long as it sees anything that's not right. There are advanced techniques of self-checking code where you can write a function to validate data structures or anything that could go wrong during your program execution, and crash immediately when it sees something going wrong. If you don't have those, and if the program actually goes wrong, we want to avoid this. You should have assertion or validity checker before it actually gets printed. Okay. Next demo is on assert and debug. I'll close the file. So going back to our find sequence of intersection function, we want to put the assertion that the intersection ID is valid and that the intersection sequence is loaded. To do this, add the assertion, and we need to include the assert.h header file. In the terminal, you make ECE297 exercise 1, run tester, func, intersection. We should still be passing the test because the tester is always giving you valid intersection IDs. Now, this is something that's also useful, and you'll see this for the first time. Change the run tester to debug tester for func intersection test. And what this does is, if you go to the repo, you'll see a few new files being added to the tests folder. And this file contains the actual unit tests that's being run for this test, for the functionality intersection test. So we have in this suite, the struct base struct for the map fixture, and test fixtures. We have the first test for intersection street segments. That's the one we're running. We have a few test cases, and we have 2 more test fixtures for functions that we have not implemented yet. So I'll delete them. for now. Configurations. You should be setting the configuration to unit test debug or unit test release or debug check. Has to be unit test. Build target all to work for everything. And the launch target to test the libstreet map. Build. This will build and launch the unit test. You'll see in the terminal it says one test passed. Because we're only running one test now. And now in one of the tests, let me change the valid intersection ID into something not valid. -1. Build and run. Now we'll see that the assertion failed. And it tells us where this assertion failed. It's in m1.cvp66. And it tells us what this assertion is checking for. So it failed as long as it sees something that's not correct. And let's test the define and debug flag. Remember, this has to be before assert.h. Include this. Now make again. Run again. We're seeing a different message. Before it was abort. In this case, it's telling us unhandled exception. In ECE297 check equal. And that's the test case. So the program actually continues until it segfaults. And usually segfault doesn't give you anything that's useful. And debug deactivates the assert. As I just showed you. The debug tester command is actually very important for you to debug, and it can be used to start the debugger. Like this. You can open this in the debugger, and you can even set breakpoints inside the unit test. And you can step into. I'll show this in the detail next week. Next week we'll be on debugging. Okay. So summary, keys to maintainable code. Your code will be read more than written by you, by others. So make it readable. Code will be modified many times. When you're adding in some lines to your functions, be aware that the function will grow bigger and bigger. So if you can, make helper functions to avoid repeated code and to keep your functions small. Keep the tests with the code so that you don't have to explicitly run the tests. You're confident that some part of your code is always correct because it's automated. so you can rerun often. Keep the documentation with the code using comments. Comments should be saying why than how. Higher level comments are the most important comments and have a big block of comments at the top of all of the header file that you're adding. Keep a block of comments at the top of the data structures you're creating. Group data structures together, etc. And if your code is clear enough, then consider not using comments. Code reviews. Read each other's code and discuss and learn what's readable, what's not. According to Google, changes should not be committed visible until it's reviewed and approved by someone else in your team. You can see the milestone 1 project management and code style rubric on Quarkus. That looks like this. This will be the rubric that your TA is going to use. Here are the additional resources on coding style. If in doubt, you can check the Google style guides. And that's it for today's tutorial. Thank you for coming. And if you have to miss part of the tutorial, check the recording.